Hi to everyone. MEM School of Engineering, Department of ECE, online classes. Subject linear integrated circuit, unit number 5, chapter number 4, voltage regulators. That is, there are three types of voltage regulator we are going to discuss in this chapter. That is a fixed voltage series regulator, adjustable voltage series regulator, and IC723 voltage regulator. Let's see one by one. So what is the need of voltage regulator in the main condition? We need different power supply for the different unit. For example, in computer, we have different power supply. So only we are using switched mode power supply. Okay, so switched mode power supply also is called voltage regulator example. Here we have one operation amplifier, Zener diode, and resistance and power transistor. So these are the circuits will be defined the voltage regulator output. So we have a regulator power supply, the voltage regulator circuit using an emitter follower circuit. Zener diode is simple to draw the memory if you understand the working of principle. This type of circuit provides a better load regulation than a simple Zener diode and resistor alone. In addition, if we make R1 a variable resistor, then the output voltage could be varied for a large range of voltages. For this op-amp circuit, we use the operation amplifier as a comparator, and the two voltage levels that we are comparing are the regulator input reference and final output. The fixed voltage series regulator, that is input and output we are giving, that is MC780XX. These are the models of different voltage regulator. 7805, it will be a minimum voltage will be 7, output voltage will be plus 5. So same as 784 will be minimum input voltage is 30 volt, output voltage will be plus 12 volt. So adjustable voltage regulator. So it will be varying the different voltages. Okay, for example, we have adjustable voltage regulator in the fan. So if we are changing the 1, 2, 3, 4, 5, it will be change of the it will be define the speed of the change in the fan. The voltage under the feedback resistor R1 is a constant 1.25 voltage reference voltage. V reference produced between the output and the adjustment terminal. The adjustment terminal current is a constant current of 100 μA. Since the reference voltage across the resistor R1 is constant, a constant current it will be flow through the output voltage. So this is the DL voltage power supply. So plus or minus 15 volt we are giving to the process. IC723 voltage regulator. So this is the model which is using the different that is variable voltage regulator. We have a 14 pin package, that is current limit 2, current sense 3, current 4, then power supply V reference like that we are giving in the IC741. This is the low voltage regulator using IC723. We can design different kind of functional diagram of the voltage regulator. So next one is switched voltage regulator. Switched mode power supply or SMPS are becoming commonplace and have replaced in the most of the cases in the traditional linear AC to DC power supply as the way to cut power consumption, reduce heat dissipation as well as size and weight. So switched mode power supply can now be found in most places, most power supply, TVs, DC motor drives, and just about anything that require highly efficient supply. As switched mode power supplies are increasingly becoming a much more mature technology. By definition, a switched mode power supply (SMPS) is a type of power supply that uses semiconductor switches technique rather than standard linear method. Standard linear methods to provide the required output voltage. The basic switching converter consists of a power switching stage and a control unit. The power switching stage performs the power conversion from the circuit's input voltage V in to its output voltage V out, which includes output filtering. The major advantage of the switch mode power supply is its higher efficiency. So compared to the standard linear regulator, and this is achieved by internally switching a transistor between its on state and its off state. So both of which produce lower power dissipation. This means when the switching transistor is fully on and conducting current, the voltage drop across it is at its minimal value, and when the transistor is fully off, there is no current flow to it. So the transistor is acting like an ideal switch. So next one, buck switch mode power supply. The buck switch mode is a type of switch mode power supply circuit designed to efficiently reduce DC voltage from the higher voltage to a lower one. That is, subtract bucks the supply voltage, thereby reducing the voltage available at the output terminal without changing the polarity. Okay. The buck switch regulator is a DC to DC converter and one of the simplest and most popular type of switching regulator. This is a buck switch regulator model. So next one, buck boost mode power supply. The boost switching mode regulator is another type of switching mode power supply circuit. It has the same type of components as the previous buck converter, but this time in different position. So both converter are designed to increase the DC voltage from lower voltage to higher one. So this SID adds to boosts the supply voltage, thereby increasing the available voltage at the input terminal without changing the polarity. We say previously that the buck switching regulator uses a series switching transistor within its basic design. This is the model. So this is the working diagram of the switch mode, buck boost and buck lag, buck switch mode power supply. So buck boost switching regulator, it is combination of buck converter and a boost converter that produce inverted output voltage which can be greater than or less than the input voltage based on the duty cycle. The buck boost converter is a variation of the boost converter circuit in which the inverter only delivers the energy stored by the inductor into the load. The basic bus boost switch mode power supply circuit is given below. Okay, this is a monolithic switching regulator. This example we have comparator, then different models of monolithic. So step down switching regulator, step up switching regulator, like that we have models. Okay, they are not mainly used, but we have to know the different models. Okay. So that is monolithic switching regulator, that is a MU-A7840, consists of temperature compensated voltage reference, duty cycle, controllable oscillator with an active current, limit current, high gain, comparator, high current, high voltage output switch, power switching diode, and uncommitted op-amp. Okay. So then step down inverting operation. So operation from 2.5 to 40 volt input. So 80 dB line and load regulations. Output adjustable from 1.3 to 40 volt. Peak current to 1.5 ampere. So the variable frequency will be duty cycle device. So the comparator modifies the off time of the time of the output switch transistor Q1 and Q2 in the step up and step down modes. And the inverting input connected to the output terminal via the voltage divider. Okay, so that's all the voltage regulator concepts. So next class we will see the audio amplifier and video amplifier, then isolation amplifier, like that we will discuss in the next class. Thank you.